So go ahead and skip a page in your book to logarithmic functions. We're going to be graphing them today. And so I'm going to show you how in your graphing calculator to type in logs when you graph them. So remember that a logarithm function, b is your base. So it will look like f of x equals log with your base be x. And remember, like if you look at this first one and you don't see a base there, we know that it is 10. So if you wanted to put this in your graphing calculator, you would have to use the change of base. So if the base is b, you would have to put log x over log 10. But since your calculator reads it, we can just put it in as log x. So if this number was a 7, we would have to put log x over log 7 to graph it. So let's go ahead and just put log x. So go to y equals, make sure it's cleared, put in log and then x, close the parentheses, then press graph. And we're just going to sketch this function here. So it's going to look like that. If we take an exponential function and we go to y equals 10 to the x and we graph it, it looks like this. So they look pretty much have the same shape, they're just going in different directions. So what these are is these are actually inverses of each other. So let's go to number 1, and we have log base 3 of x. And remember what I just mentioned here, we're going to have to put in our calculator like this, log x over log 3. So if you go to y equals, you will need to type in log x, make sure you close the parentheses, divide by log 3. Close the parentheses, and now hit graph. Now the thing is, when you have an older calculator, it looks like the graph stops here, but it doesn't. You have an asymptote here at 0, so it goes and it gets very close to it. So if you go to second table, you are going to see that you have an error after 0. That means that this line will not touch, nor will it cross 0. So let's go ahead and make some points here. We have 1, 0. We have 3, 1. And then we have 9, 2. And like I said, it will go close to 0, but it's not going to touch it, nor is it going to cross it. So now we're going to go ahead and for the domain, our domain, it does not go past 0. Our asymptote is not our y this time like the exponential, it's actually going to be our x. So x equals 0 because it cannot cross this vertical line. And remember, for asymptote, you just can't put 0, you have to write the equation of the line. Our domain, how wide it is, it's not going to equal 0, but it's going to start from 0 to infinity. Our range is from negative infinity to infinity. As far as an x-intercept, we're not going to have a y-intercept because it can't be on 0. So we have 1, 0 as our x-intercept. It's increasing from 0 to infinity. And remember, we are reading the x values for increasing or decreasing. So that's why it can't be negative infinity because it cuts off here at 0. It is not decreasing anywhere. And our end behavior, as x approaches, it never goes towards negative infinity. So the limit of f of x as x approaches 0, because on the left side we're approaching 0, it equals negative infinity because the end is going down. the limit of f of x as x approaches positive infinity, this end keeps going up and up, it's positive infinity. Okay, so let's go to, I'm just going to show you how you would put this in your graphing calculator. Again, you would write log of x divided by log of 1 divided by 2. So let's just practice that. So y equals log of x and divide by log of 1 divided by 2. Make sure you close the parentheses, and when you hit graph, it should look like this. Okay, let's go to some more trickier ones and some natural logs. So let's look at natural log of x. Go to y equals and just type in natural log, which is right below your log sign, and then type in x, close your parentheses, and hit graph. And again, it looks like it's stopping here, but it's not. It keeps going. So hit second table, and let's go ahead and find some exact points. We have 1, 0. 0 is error. That's where asymptote is going to be at, right here. Let's see if we can find any other points on here. So 8 is 2.07, so let's go over 8, 1, 2, 3, 4, 5, 6, 7, 8, up 2, and a little bit above that. So it kind of lets us see how close it is to the y-axis and x-axis. Okay, so let's go ahead and do the domain. The domain, again, is from 0 to infinity, not including 0. Our range is negative infinity to positive infinity. Our x-intercept is at 1, 0. Our asymptote is a vertical line, so it's x equals 0. Remember, for increasing or decreasing, we're following the x's, so it starts increasing from 0, not including 0, to infinity. It does not decrease anywhere. And our end behavior, the limit as of f of x as x approaches negative infinity, it's approaching, oh, I'm sorry, there is no negative infinity, as it approaches 0 equals negative infinity. So the graph never goes to negative side, so it approaches 0. And as the limit of f of x, x approaches positive infinity, the end keeps going up to positive infinity. Now when you have adding or subtracting next to it, when you put this in your calculator, you would do the change of base for this part. So log of x divided by log of 1 divided by 3, and then you would just add plus 1 after it. So go ahead and try to put that in your calculator. I'm going to do it in mine, and let's make sure that you have what I have and you're doing it correctly. So log of x divided by log of 1 divided by 3, close your parentheses, and then add 1. And then hit graph, and it should look like that. And if you have trouble, you can try Desmos if that helps you, but you do need to know how to use it on your graphing calculator. Okay, let's go ahead and try a couple more. So let's do number 6. So on number 6, this we have to write as change of base. So log of x plus 5 divided by log of 4, and then we're going to subtract 2. So let's go to y equals. I'm going to clear that out. So So log of x plus 5, close the parentheses, divide by log of 4, close the parentheses, and then subtract 2. Hit graph, and that's what it looks like. Again, it looks like it stops here, but it really doesn't. It's just the difference between the older and the newer calculators. And some of yours may have a line up here that just kind of shows you the asymptote. So if you always go to the table and begin to see where the error is, that gives you, lets you know that your asymptote is going to be at -5. Which makes sense because our transformation here would mean left 5 and then down 2. So let's go ahead. There's a -4, -2, so we can graph that. -1, -1. And let's kind of look at this and see that it will go past 0. So we don't have a horizontal asymptote. As you can see, it just moves in small increments. We do get 0, and then we get past 0. So, but this is good enough for me to have just a couple points. And slowly it will go, then it will go above 0. So our domain here this time starts at -5 to infinity, not including, -5. Our range will be -infinity to positive infinity. Now our x-intercept, when we looked at our table, we're looking when y is 0, it's 11. So our x-intercept is 11, 0. Our asymptote is going to be x equals -5. It's increasing from left to right, so it begins at -5 to infinity. It does not decrease. And then our end behavior is as x approaches, the limit of f of x as x approaches -5, it goes down to -infinity. And then the limit of f of x as x approaches positive infinity, it's also positive infinity. So what I'd like for you to do next is go ahead and do the worksheet, and then I will post the answer so you can check to make sure you have done it correctly.